Hello, my name is Marnie Peterson, and today I'll be talking about systems of equations in two variables, specifically how to solve them using substitution. So we will look at reviewing basic concepts about systems of equations, applying the substitution method with linear and nonlinear examples, and we will briefly consider systems with rational versus non-rational, in other words, irrational coefficients. So let's review what we know about systems of equations in two variables. A linear equation in two variables can be written in the form ax plus by equals k, where a, b, and k are constants and a and b are not equal to 0. A pair of equations is called a system of linear equations because they involve solving more than one linear equation at once. And a solution to this type of system consists of an x value and a y value that satisfy both equations simultaneously. The set of all solutions is called the solution set. So let's start off by um, looking at our substitution method, which is one of the three methods that we have to solve systems of equations. The other two are graphing and elimination. Today we'll be focusing on the substitution method, and to perform this, we will follow these three steps. So step one is to choose a variable in one of the two equations and solve the equation for that variable. Once we've done that, step two is to substitute that equation we found into the other equation and solve for the remaining variable. Now, once we have a value from the variable of step two, we can use that to determine the other variable. To do this, we will use the equation we found in step one. Please note that when we are using the substitution method, we will always use step one and step two. However, we may not always have to do step three. Step three relies on finding a value in step two. Sometimes we don't find a value. Sometimes we find either a number equal to itself or a number not equal to another number. And these are the three types of solutions that can result. And that is our one solution, in which case we would have a value where we could substitute that in for step three. If we don't have that, then we either have no solutions or infinite solutions. So once again, those first two steps we will always use, but that step three does rely upon finding some value in step two. So looking at these three steps, let's go ahead and use them to solve some examples. The first example we'll look at is a linear example. We have negative 2x minus y equals negative 2, and 4x plus 2y equals negative 7. So step one says we are going to choose a variable in one of these equations and solve for it. So let's consider that first equation and let's solve for y. If we have negative 2x minus y equals negative 2, we can use our inverse operations. So we'll add 2x to both sides, which gives us negative y equals 2x minus 2. And now we can divide everything by negative 1, leaving us with y equals negative 2x plus 2. So now that we've found this equation, we can take it and substitute it into our other equation. And that's our step 2. When we substitute y equals negative 2x plus 2, we will have 4x plus 2 times the quantity of negative 2x plus 2 equals negative 7. And now we can solve or evaluate. So we'll use our distributive property to multiply our 2, which will give us 4x minus 4x plus 4 equals negative 7. Note that 4x minus 4x is just 0. So we have 4 equals negative 7. Note that we did not find a value. We did not find our x equal to some number. We found 4x equals negative 7, which is not true. So this tells us that this system has no solutions. And if we were to graph this, we would find two parallel lines that would never intersect. Let's consider another linear example. So this linear example, note that the first linear example had all rational coefficients that could be expressed as fractions. In the second example, we'll see if we can use a substitution method to solve a system that has irrational coefficients. So we have the square root of 2x plus y equals 5, and pi times x minus y equals 2. Well, we'll follow the same three steps. So let's consider the second equation this time, and let's solve it for y. Well, we can subtract pi x on both sides, leaving us with negative y equals negative pi x plus 2. And now we can divide everything by -1, leaving us with y equals pi x minus 2. So now for step 2, we are going to take what y equals and we'll substitute it in to that other equation that we have, which will leave us with the square root of 2x plus pi x minus 2 equals 5. Note that when we're combining our like terms, the square root of 2 plus pi, we can't actually add those together, but we can write them as the quantity of the square root of 2 plus pi times x minus 2 equals 5. Well, now we can add 2 to both sides, leaving us with the square root of 2 plus pi times x equals 7. And now we can divide on both sides, giving us x equals 7 divided by the quantity of the square root of 2 plus pi. Since we found a value in this step 2, we are going to take that value of x, we are going to substitute it back into that equation we found in step 1, and that will allow us to find our y value. So we have, when we substitute, y equals pi times 7 divided by 2, the square root of 2 plus pi minus 2. Note that we can't actually simplify that, and so if we do want to write it as one term, we can turn it into a decimal. So when we write our x and our y as our decimal, we find our one solution with an x value of 1.536501 and a y value of 2.827060. So we find that when we do have those irrational coefficients, we can solve using the substitution method. Please note that we can solve, but sometimes depending on what your equation looks like, it might be easier or more efficient to use either elimination or graphing. Now that we've looked at linear examples, let's consider non-linear examples. So we have 6x plus 2y equals 10 and 2x squared minus 3y equals 11. And this 2x squared right here, this x squared, this is why it's not linear. But we will still follow those same 3 steps. So let's rearrange this first equation and let's solve for y. So we can subtract 6x on both sides and then divide everything by 2 to leave us with y equals 5 minus 3x. Now the second step is the same. We're going to take what y equals and we are going to substitute it in to that nonlinear equation. And that will leave us with 2x squared minus 3 times the quantity of 5 minus 3x equals 11. When we multiply, we have 2x squared minus 15 plus 9x equals 11. So note, with our x squared and our x, we can't combine those, but what we're looking at is something that we can turn into a quadratic equation. So let's set this equal to 0. We can do that by subtracting 11 on both sides, and then when we rearrange it to standard form, we have 2x squared plus 9x minus 26 equals 0. Now at this point we could factor, or we could use the quadratic formula. This actually factors very nicely into 2x plus 13 times x minus 2 equals 0. And now we'll set 2x plus 13 equal to 0 and x minus 2 equal to 0 to find that x is either negative 13 divided by 2 or x is equal to 2. Note that since it was quadratic, it makes sense that we found these two x values, right? Two solutions, since it was that x to the second was our highest degree. Since we found two x values, we need to substitute them both back into that equation from step 1. So when we substitute negative 13 over 2 in, we find that y equals 49 over 2. And when we substitute x equals 2 in, we find that y equals negative 1. So we have our solution set of two solutions, which are negative 13 over 2, 49 over 2, and the ordered pair 2, negative 1. Let's consider one more nonlinear example. Negative 6 times the square root of x plus 2y equals negative 3, and 2 times the square root of x minus 2/3 y equals 1. So same 3 steps will follow. We'll look at that first equation, and we will isolate y. So we can add 6 times the square root of x on both sides, and then we can divide by 2 in order to isolate y. So we find that y equals 3 times the square root of x minus 3 over 2. Now when we substitute that into our other equation, we have 2 times the square root of x minus 2/3 times the quantity of 3 square roots of x minus 3 over 2 equals 1. Now when we distribute, we find 2 times the square root of x minus 2 times the square root of x plus 1 equals 1. Note that 2 square roots of x minus 2 square roots of x is just 0, so we find that 1 equals 1. This is true, so this is the case of infinite solutions. And that would be our final answer. Note that since we did not find a variable equal to a number, we don't need to do that step 3. We just have our final answer of infinite solutions. Thus, we have looked at solving with the substitution method when we have linear or nonlinear and rational or non-rational coefficients. Thank you very much.